As we learn linear regression, sometimes we refer to linear regression we studied as OLS, that is ordinary. So what is ordinary about? We're going to talk about that. The ordinary linear regression, what we do is try to estimate the parameter in some linear regression model, right? So you try to minimize the sum of squares of the residue, which is the error term, when we try to fit the model to the sample data. You can formulate the linear regression as a line fitting, where the blue dots are the observed value and the red one is your prediction using a linear regression or line fitting model here. And the parameter here, of course, for linear model with one variable here, you're going to have the slope and intercept. In linear algebra, we may formulate the problem as the following. That is your observation x and your prediction for y, and here is a matrix. It's called design matrix. You're going to have a multiple observation, and x is multiple variable here, right? So it's like m by m matrix here. Now here beta would be the coefficient, is a vector of the parameter you want to estimate, and epsilon here is the error term. Estimate of beta from the sample would be a solution to what is called normal equation in linear algebra. So that would be the expression here. The what is called mean square error formulation. So we try to minimize the prediction that is represented by y, this beta 0 plus beta 1 xi here, with yi, which is a true value from the sample. Here, of course, we use one variable formulation. N would be the number of samples we have. So yi is the actual outcome from your sample. Xi is the predictor value. And this beta 0, beta 1 would be your parameters. Now, you can use calculus to solve this, right? The two variables. And sometimes we use what is called maximum likelihood setting. That is, you assume the error term would be a normally distributed errors, and this likelihood would be the beta parameter, right? Is where after you observed the samples, what is the likelihood that the relation is governed by this beta value, right? So you try to maximize this MLE. And this actually, if you do some math, this will give the same results as you would if you're going to use minimize of mean square error. The reason we say ordinary is because there are other regression methods, for example, ridge regression, where we add some penalty terms to the quadratic of the coefficients, right? Nassau regression is also very useful. Sometimes we add what is called R1 norm. And this is useful sometimes for the feature selection. If you have multiple features and then use Nassau to suppress the less significant variables. And there's robust regression, weighted least square, a generalized least square, and quantile regression. And all those sometimes are useful if in your probability model the variance of the error term is not constant, or the error, however, is not independent. There may be correlated error terms, right? And so you need to use advanced models like those. The Bayesian linear regression is where you have some knowledge on the prior distribution of the parameters. So that will also be something you're going to learn in the stats or machine learning class. Even though the linear regression we learn is ordinary, it's still a powerful method. It is a foundation for a more advanced mathematical concepts. So it's going to be a cornerstone in linear regression modeling. For these and other math or computer science topics, please like, share, and subscribe to the channel.